Hi, everybody. Mike Napoleon here with SuperSpeed Golf. Welcome to another SuperSpeed Golf webinar. We're very excited to have some special guests here today. Some of our friends from SportsBox AI, Phil Cheatham, who's a personal mentor of mine on all things 3D motion capture. So, Phil, thank you very much for being with us. Also, Nate Ashton, who's what's the count of PhDs on this webinar today? All right, is it a full three? Do we have three? No, not
No,
quite. All
not
right.
quite.
Well, still some extremely advanced biomechanists on this webinar call. And of course, everybody knows our good friend, Dr. Tyler Standiford, who you have probably seen many times before. Also, Paul Park, who's going to be hanging out with us, who also is kind of an expert in all things Sportsbox AI specific. Um, as usual, we're going to go through a little bit of a presentation for everyone. If you have questions, please type those in the question and answer pane. Tyler's going to be hopping back on the back end here and answering a few of those as we go. And we'll also answer a number of those live as well. So anyway, thank you guys for being here today. Really appreciate it and looking forward to hearing everything that you have to help us with about, sequencing and 3D technology. All right, I'm going to go ahead and get this slideshow started. And share everything up here. Stop 2. All right, I think everybody should be able to see where we're going with this now, at least to start. So, just as we get started here, I think there's probably a little bit of confusion out there in the world of just, what is 3D technology? What are we looking at? And we're going to get into all of those bones. But, Phil, I'm just really interested because we've worked together off and on various projects. I think one of the first times I remember meeting you was back in Phoenix, actually at a seminar you were teaching for the AMM systems that you had created. So, I mean, how long have you been doing this?
Oh, quite a long time. I've got a few slides where I'll talk about it a little bit, but basically speaking, my first motion analysis system that I developed was for my master's degree back in 1980. So what's that, 45 years, something like that? It's quite a long time.
That's getting there. I was born in 1982, so I guess we're going back before me and Tyler and probably Nate here for sure. So anyway, it's really a pleasure to have you guys on. Here at SuperSpeed, we talk about rotational sequencing, about how the different parts of the body move, how those interrelate, and how that can affect speed and power in the golf swing. And really, we use 3D technology like 3D motion capture systems or Sportsbox to analyze that, to find where there's power leaks, where there might be strengths for that player, and then to use that to build programs. So I want everybody out there to understand that this isn't just about like how do we analyze that data, but we really want to look at also how do we use that analysis to help people get better. And we've got some really cool stuff to look at. We've got some stuff about Bryson DeChambeau in here that we're going to present a little later. So definitely stay tuned and make sure you take a look at that. You guys have seen this model from us here at SuperSpeed before. Tyler and I have talked about the speed pyramid for a long time. And, again, this model is just about what affects speed and power in the golf swing. And, we like to say that player is going to interact with the ground. Those forces and torques are going to have an effect on the way their body rotates and sequences. Now, in addition to the ground, you're also getting interaction from how the muscles work, how we control the different muscles of our body. We really call that rotational sequencing. And as we get to the top ends of that rotational sequencing chain, we're really looking at how that's going to affect sequencing in the arms and hands, and then that eventually getting out the club, to the ball, hopefully with optimal amounts of efficiency. So that's our speed pyramid. Today, we're really taking a look primarily at that middle section and a little bit talking about how it gets up into the arms and hands. Now, before we get in there, we always like to give you a little bit of background. So I think it's important to know what we're actually looking at when we're measuring different types of 3D technology. And, Tyler and Phil, I'm going to say this, and Nate, let me give this a quick go, and you guys can give me a grade after that on if I was in your class at university and how I'm going to do on this motion thing, okay? Because I really want to give it a try. You know, I look at this like when we were back in school, right? And we started started trying to put graphs on plots, and we had this x-axis and this y-axis. And for me, I thought the world was really simple when all we had to deal with were those two. But all of a sudden you start adding in 3 dimensions and you put that other axis in there, and I mean it just makes everything a lot more complicated. But when we talk about how we move in space, we can move up and down, we can move left and right, we can move to and from a target. So if we're looking at the golf ball, we've talked about vertical force and, jump force. That's up and down. We can move left and right, lateral motion. We can move to and from the ball. Kind of call that like anterior, posterior motion. And then, so that's 3 different motions that we like to call translations. And we can measure that on video. Very crudely, and there's some other great technology we'll show you guys soon where we can measure it very precisely. And that gives us 3 degrees of motion that we're looking at. Now, the next thing that complicates this further is that we can actually turn or rotate around each one of those axes. And once we get those 3 different rotations in, that's what we call 6 degrees of freedom, or the ability to move in space in any direction and at the same time rotate around any of those different directions. All right, what do you think? Is that pretty close? A good overview?
That was good. Yeah, you did that very nicely.
All right, well, thanks. I mean, I'm just a golf coach over here, so I'm trying my best to keep up. But now, I really, Phil, what I really want to look at now is I'd love to know a little bit about some of the history of how this all started. Like, where did motion capture technology start? How did we start doing this? And really, where's it gone?
Okay. Well, yeah, we can, like I said at the beginning, we can go way, way back. In the 70s, they were using film, and Dr. Gideon Ariel was one of the first ones to ever do it from 16mm film. But then I had a job at the US Olympic Training Center, and film was just too time consuming because you had to send it away to get developed, and you didn't know whether it was going to be overexposed or underexposed. And we had training camps that would come in and they'd want to have their data the next day. So basically biomechanics was a bust at that time, until I was given a project to develop a video digitizing system based on the old IBM XT PC and using a VCR. Probably a lot of people don't even know what a VCR is anymore, but basically a video cassette recorder. So we'd go out and we'd put it in the cassette recorder, we'd play the video, and I developed a way to capture the images onto the computer screen, and then using your mouse, you would put your cursor on the wrist, the elbow, the shoulder, the hip, the knee, and you create a stick figure, and then you click a button to go to the next frame, and you do the same thing, maybe 20 points, and then you do the same thing. So think if you're talking about just simply 120 frames a second and 2 seconds for the golf swing, that's 240 frames you've got to go through. But on the other hand, we didn't have to wait for the film to come back. So we would literally pull all-nighters, digitizing from video to give the athletes data the next day at their training camp. And so that was really the first episode, if you like, of being able to analyze an athlete's motion. The cool thing about it, though, is because we were putting the cursor on the athlete, we didn't have to put any markers or sensors or wires or anything onto the athlete. So we could just go out to the training field or to the gym, film them, come back and do the digitizing without them necessarily being disturbed. So that was awesome, but it just took too long.
Yeah, you just had to stay up until like 4 in the morning to give them their results the next day.
Yeah, exactly. So we were looking for alternative methods. And if you'll go to the next slide, you'll see, no, go back one. Yeah, that one. You'll see that over the next 40 years, companies came out with a lot of different solutions. And you've got the ones where you put the ping pong balls with reflective markers. And then you've got others that use what we call the IMUs, which are motion sensors. and then the one in the right where you can see Dave Phillips all hooked up at TPI on the AMM TPI system. All of these had their strengths and weaknesses, but the biggest weakness is two biggest weaknesses. One is you had to set them up, so it would take time. You had to do it kind of in a lab situation. And the other weakness is they were encumbered by all of these straps and stuff all over them. Reflective markers might fall off when they're swinging, or a strap might slip. So this was great, and this was the state of the art for many, many, many years. But I always wondered in my head if we could have a magic camera, just like we had at the Olympic Training Center, just a single camera where we would film, and automatically it would, 2 or 3 seconds later, it would create a 3D analysis. I didn't think that was possible, but along came SportsBox 3D Golf. And I do like to call it the magic camera because it was the solution that I was looking for. Never thought it would happen, but a couple of years, 2 or 3 years ago, it did. And now we have the ability, using artificial intelligence and, of course, much more powerful computers, which actually happen to be your iPhone. Your iPhone is way more powerful than the computers I had back in the 80s. In fact, we would have considered it a supercomputer back then. So with that powerful technology and artificial intelligence and the strength of biomechanics and the algorithms from biomechanics, we're able to come up with a system. And we can use that system to show you the 3D. And you can see from the images there, we have both the video and an avatar. And that avatar, a robot, if you like, can rotate around, and it's true 3D. It can show you down the line. It can show you from up above. And so you can really see what's going on. And it has the ability, since it's computer generated using like a game engine, if you like, it can put trajectories, it can put lines and fancy planes, and really help you in the instructional side of things. And we can give you all the numbers, all the biomechanical parameters for address, top, impact, finish, all the P1 through P10 positions. Basically all you ever wanted to know. Pretty much just as much information as you get from the multi-camera $20,000 to $30,000 systems. And it's just a subscription, and it's just on your iPhone. So yeah.
Yeah, and
Very cool.
Phil, I mean, obviously we've worked with that, and we use SportsBox with all of our players as well. Again, I've kind of been there, not nearly as long as you have working through this, but I've worked with some of the inertial systems, and again, some of those only measure how you rotate, so they don't really get the whole picture. And then I've worked with the AMM systems for a long time that you had created before, which I guess we're kind of the gold standard for a long time as far as measuring full 6 degree of freedom motion. But yeah, you're right. Like having to, and I will say, Kyle Shea and I got fast at being able to get somebody into that suit and out and digitized. I mean, we were probably in the 5 to 7 minute range of setup to swing. But the thing that got me as a golf coach with a lot of those systems is, yes, the analytical data was fantastic. We got the data. It was great. But I want to be able to do things like I want to see what data is there, analyze it, give a player some drills, and then I want to see the data after to make sure that the drills are doing what I want them to do for that player. And having to go back through that whole process of getting them back into the system and re-digitizing all of that is very cumbersome. But I mean, we used SportsBox a year and a half ago. Standing on the range with Padraig Harrington before and after drills, saw, very specific things that changed with the things we wanted. And at least then I can say, hey, I think these drills are very good for you. Go off and practice them. And I feel comfortable as a coach giving, kind of testing my drills with some of the best players in the world. So very cool stuff. It's amazing to see kind of where it's gone. Next, let's kind of get into what we're actually measuring when we're looking at rotational sequencing, just because I think this is another topic that for a lot of the players out there may not have ever seen, or certainly probably hasn't looked at it in tons of detail. I like to take this skeleton model of the body and just say, we're measuring four major segments when we start to talk about the sequencing of the golf swing. Now, there's more body parts than these four segments, and there are things that we look at in those other segments as well. But the primary ones that we like to look at how fast they're rotating in the thing, start with the pelvis or the lower body. The next piece is, we call it the thorax. It's really your rib cage or upper body, how that turns. Then we're looking at your arm, kind of specifically kind of the lead upper arm part here, without really a lot of elbow interaction. And then we're looking at the club. And different systems measure these different pieces in slightly different ways. Phil and Nate, like SportsBox specifically, when we're looking at these four segments, what are we looking at specifically in the data in a SportsBox rendering?
Well, the reason that SportsBox hired me way back in the beginning was to basically hijack all my AMM knowledge from what I've done over the last 20 years with AMM and TPI. So the algorithms that we're using in SportsBox are identical to AMM and TPI. So we're talking about the rotation speed of the pelvis, and I'll get into this in detail in just a second. Then the thorax, we call it the chest because a lot of people never understood what the thorax was anyway, so we call it the chest. And then the lead arm and the club, as you've already mentioned. So let's get
Well,
into
I'm old school, so I'm staying with thorax, but we can say chest from, I guess we have to move on. So Phil, this is obviously one of those very famous graphs that, you've probably done presentations on for the last 20 years, called the kinematic sequence. Why don't we walk through a little bit here for everybody, kind of what we're looking at, because these colors correspond to what we just showed as well, right?
Yeah, well, we developed this algorithm, this series of curves or graph, if you like, way back in the early 2000s. Dr. Greg Rose and I came up with this. It was basically based on research from the biomechanics literature, and we kind of fine-tuned it. And basically, you're looking at a graph of four curves. And those four curves are, as we just mentioned, the pelvis, the chest or thorax, the lead arm, and the club. And they go just like you saw in the diagram, red, green, blue, brown. And on the y-axis or the vertical axis, we have angular velocity, which effectively is just basically your rotation speed, how fast you're turning in degrees per second. Now, along the bottom axis is time. So that's your progression through the swing. And there's different key points in the swing that we highlight by vertical lines, red, black, whatever, but vertical lines. We have address, top, impact, and finish. We didn't do all the 10 key points because that would have been way crowded, but we can get measurements from those as well. And I'll talk about that when we get a little deeper into SportsBox. But then you're also divided into what we call phases. Since between address and top is back swing, and then between top and impact is downswing. And then, of course, from impact all the way through to the finish position is follow through. So those are the three key phases in the swing.
Outstanding. Yeah. One of the things, Phil, that I've always,
Let's go back
always,
to that. Yeah, let's
sure.
go back to that for a minute. Stay on that slide. And yeah, go ahead.
Yeah, what I was going to say is just, as a golf coach, one of the things that I've always liked about looking at the kinematic sequence graph is it really shows that the golf swing doesn't happen in like choppy segments of the swing. All of these pieces of the body are moving and interrelating throughout one big motion that becomes this pattern of movement, that we call the kinematic sequence. I always think that's really important for people. I think there's a lot of players out there that get very stuck with like trying to get to a position in the swing and then be able to move from that position to the next one. It's like, well, this is very difficult to do because when you do this entire motion dynamically, these components are moving in different ways as you go and changing direction at different times. And all of that is really important to the magic of the golf swing.
Yeah, and the beauty of this graph is it shows that the swing is not just one motion. All your body parts do not turn at the same time, at the same speed, and just want to be maxed out at impact. In fact, if you look at the area right in the middle there, you see the red curve. They all start out, yeah, they all start out close together. They all start to turn, but then they sequence. That's why it's called the kinematic sequence. The pelvis reaches its maximum speed first, then decelerates. Then the chest or the thorax, and then decelerates. Then the lead arm swinging, it reaches its maximum in sequence after those two. And then finally, the club shaft. The only one that doesn't decelerate before impact is the shaft and the club head, because of course you want that to be maxed out at impact. But all the other parts of your body actually accelerate and decelerate into impact. And that was beautiful when we discovered that and came out. And there's so much information that you can glean from just those four curves, which I'm going to talk about now.
Yeah, let's get into it.
All right. So, like I said, we call it the kinematic sequence. Sequence, you obviously understand. We're talking about the sequencing of the body parts. But the word kinematic, well, kinematic means motion, really. There's a difference between kinetics as forces and kinematic as motion. So because we're measuring rotation speed or rotation velocity, it's called the kinematic sequence. And there's a lot of data other than just the sequencing. Yeah, it's important to go 1, 2, 3, 4 and get those peaks, like I've got the dots on there, get them sequential. But there's also a huge amount of hidden information in these graphs. Like, what's the peak speeds that you reach with your body rotations? What's the speed gain that you get across each joint and with the muscles? And just like in a launch monitor, we can calculate what we call gain factors and the percent contribution by each joint to the total swing. And then that allows us to analyze where your strengths and weaknesses are.
Yeah, absolutely. I mean, I'm even just looking at your little kinematic downswing graph that you have here and saying, this is a player that's like lagging the club and creating downswing loading between the wrist and the club really, really well, but there's probably some gain that we could get with like the bigger segments of the body. So, and again, I've been looking at these things for a long time, but it's like those things pop out to me right away when we're looking at this kind of 3D motion data. And, if you're out there searching for a coach that, knows how to use this type of stuff, I mean, it's like cheating in a lot of ways as far as finding the fastest way to help you get better or to get more speed, being able to, see this data for yourself.
Yeah, and that little secret, I said there's lots of hidden gems in there. That little secret that you just mentioned is just because the blue curve is on top of the brown curve for a little section there, and that's indicative of lagging. So there's huge amount of information. Anyway, let's pull it apart. Let's look at some of this information piece by piece. The first and most obvious aspect of it is the maximum rotation speeds. And we just basically pull those points straight off the graph. And we see that the other thing I want to mention too is you can see 480, 730, 1000, 2280. Those are numbers from a tour database. So we have a tour database. AMM tour database is about 100, and now we're rebuilding all the SportsBox databases. So we'll have them out as well for not just a driver, but also the mid irons and for men and for women on the tour, so that we can compare you to what the best guys in the world are doing. And yeah, it may be a little disheartening sometimes because you're not anywhere near as good as they are, but it gives us an indication of where your strengths and where your weaknesses are. So as I said earlier, the chest turns faster than the pelvis. The arm swings faster than the chest. And finally, the club swings faster than the arm. And the speed increases across each joint by the abs working for the core, the shoulder, and the wrist muscles all speeding up the next segment in the chain. So the other picture that you see there is where these peak speeds occur. And I think that's really cool looking at that, because I know when I started looking at this that I didn't expect the pelvis to peak so early in the downswing, basically lead arm parallel. And that's after that point, the pelvis starts to decrease. And why does it decrease? Well, it's transferring energy up the chain to the next part of the body. And the core muscles are adding to that energy. So that's why you get an increase. That's that white space between the 480 and the 730. That's the increase in speed. So the next thing that we can do is we can find how much speed gain you got from each of them. That would be the next slide. And now you can subtract the peak, one peak from the other, and get the difference. And that 240 is the difference between what it was before on the previous graph, which was 480 and 730. You just subtract 480 from 730 and you get the 240 degrees per second. That's how much extra speed your core muscles have added to the swing. And the same with the shoulder. It's added 280 degrees per second. And then the wrist, you can see most of the speed gain comes from the wrist for obvious reasons, because that's the part that's moving the fastest. And that's, if you do it correctly, that's the whipping action that comes out and travels the energy, sends the energy to the club head. So we can use these numbers to see where you're lacking. Perhaps the green and the red curve, which is the chest and the pelvis, perhaps that speed gain was almost nothing. Maybe it was only 50, which means, and so the green is sitting on top of the red. That means perhaps you're not strong enough or powerful enough, or there's something going on with the core. And you're going to talk more about that later on, and some practical drills and some practical aspects of that when we get a little further in the slideshow. But let me jump to another one, go to the next slide. And we can see now that we can use these speed gain factors in the kinematic sequence to come up with basically the smash factor for the body. Next slide. If you know what the smash factor is for the ball and the club head, basically it's the increase in the speed of the ball, or sorry, the speed of the ball divided by the speed of the club head. And typically it's about 1.5. And if you have a good transfer of energy, it's going to be 1.5. But if you have a poor transfer of energy, it's going to be less. It can be 1.1, 1.2. It can even be 1.0, which means you didn't gain anything, any speed from the impact between the ball and the club head. So we've coined this same algorithm for the body. So we can look at the gain factors across the core, across the shoulder, and across the wrist. So we just simply take the 730 that we had for the chest and divide it by the 480 that we had for the pelvis. Instead of subtracting it, subtracting it gives us the absolute speed gain, but we can get a gain factor. And funnily enough, it comes out to, when we do it for each of the joints, comes out to like a 1.5 and a 1.4 for our tour pros. So it's very similar to the smash factor for the club and the ball. And we know these numbers because we've got an excellent database of tour pros. And bigger in this case is not necessarily better. You want to be able to balance these numbers because if they're not balanced, if one is way higher than the others, then that means you may be putting too much stress or too much work on that particular set of muscles and that particular joint. While I'm on it, have a look there at the wrist. The wrist gain factor there is about 2.3. So as I showed earlier, most of the speed gain does occur across the wrist, but that's not to say the speed gain from the core and the speed gain from the shoulder are incredibly important as well.
Absolutely. I mean, looking at this stuff practically, like most of these graphs we're looking at are of touring professionals. So like when you see amateurs on these, like they don't necessarily always look this good. So like you're going to see big deficiencies in different areas a lot of times. And that's something that can point a coach to the right direction really quickly.
Yeah, and again, that's how it gives you the signal as to what's going on. This is a good one for telling you where you're losing it or where you're losing power. This is percent speed contribution by joint. So basically, we just take the speed of the pelvis, divide it by the total speed, and turn it into a percentage. Then we take the speed of the shoulder, make it a percentage of the total speed, and the same with the wrist. And we see that we've got like 20% at the pelvis, we've got 12% at the shoulder, or yeah, at the shoulder, and then we've got another 10% to the arm and the wrist. And so you can look at these numbers, and a good example here is the wrist. Older teaching pros will tend to have a much bigger number than 55%. They'll probably have 60, 65%. And the reason for that is they're not as strong as they used to be in the legs, in the core, and in the shoulder, but they still know how to release the club. They still know how to swing the club. So they're getting their speed from being clever and understanding how to have a good release. So having a good release is incredibly important, but of course we want the percentages and the contributions from each body segment to be balanced. And that's the
Yeah,
other thing. If
100%.
one is too high or too low, then there's a potential for injury.
For sure. I mean, a lot of times practically, again, looking with like a data set from an amateur, we might see that they're not using their core at all. Like it's a very, very low number. So we know that there's an area there where we can get big gains really quickly. And we can also then see sometimes that there's a, we might get low contribution between the wrist, in the wrist segment with amateurs too. Those would be players that are casting the club, not creating a lot of downswing loading, things like that. So it just makes those very clear. I mean, the ideal obviously is that we can get all of those different segments working together in harmony and helping each other move faster up the chain.
Yeah. All right. And I just wanted to point out one final slide before we look at the speed profile that we've created as well, is that the body speeds do create club head speed. And the way we can verify that is we've done a correlation study between shaft swing speed max, lead arm swing speed max, chest turn speed max, and pelvis turn speed max. And they all correlate directly to club head speed. Of course, as you get closer to the ball and closer to the club head, the correlation is larger and it decreases as it goes down the chain. But nevertheless, it still stays significant all the way down to the pelvis. So that's basically all I wanted to say on that one is, yeah, these body speeds create club head speed.
Absolutely. All right, let's keep going. I want to get into some of this stuff that you guys worked on with Bryson because this is really cool. And obviously, I mean, he just won the U.S. Open and he hits it about as far as anybody else out there. So I don't know, Nate or Phil, who wants to go through some of this, but I think this new speed profile that you guys have created in the SportsBox app is really cool.
Yeah, I'll start off and then I'll hand it over to Nate and he can give you a little background of how it all worked and how it helped Bryson. But, we just talked about rotational speed. So that was the kinematic sequence. That's that box on the right there that you can obviously see marked as rotational speed. And the top left-hand box is showing what creates the rotational speed, and that's the rotational range of motion. And so you've got chest turn max and pelvis turn max and X factor. So these are some numbers we put together in our speed profile. And I'm going to talk about in the last few slides, I'll talk about a little bit about the verticals and the release and the horizontals. And this is Bryson's analysis. So you can see his superpower is definitely his rotational range of motion and his rotational speeds. A little bit low on pelvis speed, but generally way high on speeds. And if you look down the bottom, you see his hand speed is also one of the things that he's got as a superpower. But anyway, let me pass it over to Nate and explain. Nate, you can explain how we use this and other data to help Bryson win the US Open.
Yeah, and this, as you see a speed report here, more specifically, or a speed profile for Bryson, these are things that we've been able to do with other players, and this actually, some of the work we did with SuperSpeed and Patrick Harrington previously was kind of a stem into this as well, right? This is some of what we were able to work through with that. And so getting into kind of seeing this, we really like these profiles because it gives us the ability to also see where like we kind of say their superpower stands out, right? Where are they getting their speed from or generating, their most energy? And again, like Bryson, he's somebody who turns a lot, right? We see he has high rotational speeds between his chest arm and, shaft. Some of, the other things that we can see in here is not necessarily where somebody's weak, but maybe where they're an outlier. This speed profile, again, this is comparing Bryson to other Tour Pro peers, right? If you compare a beginner golf to the Tour Pros, you'll probably see a lot more red up here. But this actually gives us an idea of Bryson. A lot of people, and he himself talks about how he kind of releases the club different, right? How his grip is significantly different than a lot of other players. And that kind of goes to show here where we can see he releases the club earlier than a majority of the Tour Pros. And his wrist angle at arm 30 degrees before impact is a lot more open. It's larger, right? He doesn't wag the club as much as other players, but he does that for himself because he can generate so much rotational speed. And then for control of the face, that's why he releases the club the way he does, right? And we can go through this data, and especially in the U.S. Open, we were able to see this information and see how powerful it was from even working with him through the Live Houston event, where maybe he wasn't hitting the ball as well as he wanted to hit it, and kind of processing that data through all the different kinematics that we had with some launch monitor data to go with it, where we could then correlate certain movement parameters through kinematics with a type of more specifically spin axis of the ball that he wants. Right. So as we were able to go through that data, we were able to give a little bit of feedback from what we saw within his swing to his coach, Dana Dahlquist, which then puts it into more coaching terms. And then as we were able to get to this point of, working on certain drills with him, where Bryson started hitting exactly as he wanted, we were able to capture those swings as well to see, what is he doing when he hits it optimal, and then be able to build kind of that gold set to say, okay, hey, going into Wednesday practice round and Thursday, those are the best ball striking days I think Bryson's ever had, or at least for sure had during a major like that, right? Hitting 80+% of fairways. Being able to see that data when he was hitting it really well during the practice rounds on Wednesday compared to swings that were less optimal. We could get down to the very key point of, hey, these are 2 or 3 things that you're doing different, where you're hitting it right and it's staying right versus when you're, able to draw the ball back. And a lot of that was able to stem from looking at this information, a lot of the rotational speed information as well, not just looking at the release. But this comparison, and again, same thing going through, we could look at a mix of this information with Patrick Harrington or some other players along that line of, hey, where are they maybe not doing something as well, is where we could find some space for improvement. And that was one of the great things. Then go to SuperSpeed, right, where you can look at a lot of the different implementations of drills and things of how can you utilize and implement to help yourself get into better sequencing or, use the ground more. And I'm just kind of hitting on that to start, but I know Mike and Phil are going to cover that a little bit more, but yeah.
Yeah. Well, let's look a little more deep into some of the stuff with Bryson, because obviously every player is going to be a little bit different. I mean, we know Padraig is like a big downswing loading kind of wrist lag sort of player. Like, that's not what Bryson does at all. I mean, they both, Bryson has 190 plus ball speed. Padraig's still up in the mid 180s, over 50. So, yeah, I think it's a key point. And what I think this report and profile gives you is that it shows you how you create speed or how this player creates speed. And that can help you identify strengths, weaknesses, areas to work on. And I love that term superpower, because we always want to make sure that we're using what, the best area that we have, or that superpower, make sure we're not, trying to, focus on our weaknesses too much, if you will.
Yeah, and Jihei came up with the term superpower, and then we even coined the term kryptonite to have a look at what your weaknesses were. So your superpowers are your good stuff, and your kryptonite is where you need a little bit of a help. So kind of puts a fun spin on it. Anyway, let's get back. We kind of went off a little bit there on a tangent, but let's get back and we'll talk about the rotational, the speed profile and the speed profile report. We may go a little bit long, but I hope you're enjoying what's going on so far. Yeah, I'll talk about each one of those boxes, and we'll use Bryson as an example. So I did mention, and so did Nate, the rotational range of motion, which is how much your chest is turning, how much your pelvis is turning, and of course the X factor, which is the amount of turn of the chest with respect to the pelvis. Notice I did not say it's the difference between the two, because it is not the difference between the two. It's actually measured in 3D. So if you have side bend and forward bend, that subtraction of one speed from the other, one angle from the other, is not going to equal the correct value. Anyway, I don't need to get into the biomechanics any deeper than that, just to let you know that if you were to take the chest and the pelvis and subtract them, sometimes it won't look like the exact value of the X factor. Anyway, you can see that the rotational range of motion for Bryson was huge. He's in the 93rd percentile compared to the tour pros. And I think, what was it, Nate? There was about 50, 55 tour pros in this database that we were comparing to. Yeah. And then I've also got, we're in various stages of developing this report and these databases, and we're always improving them because our models are always getting better and better. So you can see here that this is N equals 35 for the men and N equals 39 for the women. The next iteration is going to be the 55 that we're using in the speed report. But anyway, those numbers right here, you can see the men, the chest turn is about 100 degrees, and the women, it's about 103. Pretty similar. Women a little bit higher than the men. Pelvis turns about 44, and women are 47, a little higher. And then the X factor, interestingly enough, is slightly higher for the men, but really, really similar numbers, which I thought was really cool when I saw this data coming out here. We are looking into, of course, the rest of the speeds with the women as well to see, and everyone, the men and the women, have increased their speed incredibly since we started this with TPI and we had the original AMM database. The speeds have gone way up. So that's why we want to build the new numbers. So anyway, let's move on to the next slide, please.
Gotcha.
All right. Now, we're talking about rotational sequencing, but we'll give a little quick mention to linear as well. Linear in a straight line. So we found that pelvis drop and especially pelvis lift do correlate with speed. So you can see that if you're a jumper, you've got a potential for adding speed, because if you jump or lift, if you like, at the right time, and it's all about timing, if you lift at the right time, you're going to help release the club, and that's going to help increase your speed. There's a little red fly moving around. I realized that this has an animation on it, and I forgot to take off the animation. So
It's all good.
Please ignore that. So anyway, you can see it talking about the graph there. So you can see the drop in the downswing, and you can see two different examples of the curves. And I love curves because they're a signature of motion, and they show you the differences between one golfer and the other. So in this one, you can see the drop to right where the little cursor is at the moment, and then you can see a lift into impact. Whereas on the bottom one, you can see a drop, but you don't see the lift. So in the table, what I'm showing is the difference between a long drive guy. Obviously, the long drive guys are trying to maximize their distance, and so they use everything they can. So they have like 5 inches of lift into impact, whereas the men and the women are at 2 or 3 inches. So you can see that Bryson has a 2.8-inch drop and a 3-inch. So he's not using as much lift to gain his speed. As we said, most of his speed is coming from the rotational speeds and the rotational range of motion and the hand speed.
Yeah, absolutely, Phil. I think Tyler and I have done actually a lot of kind of preliminary research on some of this, kind of connecting up kinematic sequence with, the kinetic sequence about where different ground forces start to go in. And we've started to see some very, very cool patterns that, I would guess we're probably a year away, Tyler, from really having that data ready to present. But you want to talk a little bit about that, and maybe you're late, with what you would expect to see with Bryson?
Yeah, I think it's just a cool combination. We've talked a lot about ground reaction forces, and I think as we see what a lot of amateur golfers are unwilling to do is create that shift and drop in the center of mass in the pelvis. And so what we tend to see with their vertical force is a vertical force that stays pretty flatlined in the backswing, pretty flatlined in the early downswing. And then the problem becomes it's really hard for them to create that really powerful vertical force at the end and that upward thrust of the pelvis to create a lot of speeds, because frankly, they'd missed the ball because they'd moved too far up. And so getting players to feel comfortable lessening that ground reaction force, then you see this nice drop of the pelvis so that they can be in position to utilize the ground in their body effectively.
Yeah, and that's cool because it's the interplay between the kinetics and the kinematics. It's the interplay between the forces and the motion. When you drop, you're going to unweight, and when you lift, you're going to weight. And so the forces obviously in the force plate cause the motion, but you can see it manifesting in the kinematics that we can measure with SportsBox directly from the video.
Yeah, I think a lot of what we've started to do with it is we actually use like the SportsBox kinematic data as a secondary like sign of if the player's doing the move or the drill that we're trying to get them to do correctly. You know, they're going to be seeing these changes in the amount of like pelvis drop and lift. And then we'll also see that correspond with the changes in ground force that they're going to be getting. Yeah, absolutely. There's a question right now that I think is kind of pertinent. They're asking if we can see a swing that shows that drop and lift. I don't have one right now in front of me on this, but if you just look for a swing from like Justin James would be a really good one where you're going to see a very significant amount of that drop and lift that you're going to have happen. And I think I'm not shocked that you see a little less of it with Bryson because he's such a rotational player. Like
Right.
we wouldn't, you know, he's such a rotational player that you're not going to see that as much from him as you would from a player like a Justin James or maybe a Justin Thomas or, you know, a player that's going to be moving up and down a lot more in their swing.
Alexi.
Yeah, for sure. All right, let's keep it moving a little bit here. I just want to show everybody some of our new sequencing protocols that'll be coming out with our app very soon. We are moving along on that project very quickly right now. We're hoping to have that beta ready very, very soon. But all these protocols will be available in the new SuperSpeed app. A lot of these start out with just kind of motor control. So just basically brain controlling the body, working on something that we call disassociation. So that's your ability to be able to rotate your upper body and your lower body or your pelvis independently and to be able to stabilize the other segment while you're trying to turn one of them. That motor control has a huge correlation to your ability to create efficient sequencing. This first protocol really focuses on those ability for disassociation. We start with just physical drills, then we get into a club on chest position where we start to work on some of those specific movements, gradually get up into shorter shots, really trying to get the lower body leading, and then move into some of our drills that we use all the time, like our step change of direction drill. This is going to be an exit one to start to work on those gain factors, you know, really here with the lower body between the pelvis and between the pelvis and the torso. And then we have a level 2 protocol here that's really going to start to work on the upper segment. So this is much more about torso or thorax, chest and arm connection here. So we're going to be doing drills there trying to up those gain factors. Again, starting with drills to just kind of feel the positions and then to start to actually feel the chest rotate a little earlier than the arm and then applying those to full swing. So just want to throw in some of this cool stuff that's coming out here soon from SuperSpeed Golf where we're going to have things that very specifically work on some of the data that you just saw. Now, Nate and Phil, I want to toss this back to you guys now because I do want to talk a little bit about like hand speed and some of the wrist and downswing loading characteristics. And I know you're still looking here at Bryson, who's not a massive downswing loading player. I've got a little video here and a couple of Podrig who is, so we can definitely see it there. But yeah, I'd love to hear a little bit more from you guys on this end.
Yeah, the interesting thing, though, is he does use, there's our little bee again floating around. He does use maximum hand speed, and he's very high. He's like the 92nd percentile as far as hand speed is concerned. And just like arm swing speed, hand speed does not max out at impact. It maxes out before impact. And you can see some of the times there for men and women. It's about 59 milliseconds for men and about 80 milliseconds before impact for the women. And that means the reason for that is because of the release of the club. And of course, you don't release the club right immediately before impact. You release it a little bit back, as you can see from the diagram. And that releasing of the club actually creates a torque and forces the arm to slow down slightly and forces the hand speed to slow down slightly. So if the speed maxed out at impact, that would be a very, very poor swing. So
Yeah,
yeah.
for sure. I think with most of all of these segments, like we've always kind of talked about how like it's not thinking about slowing a segment down, it's thinking about firing the next segment, and the process of making that next segment move fast forces the segment below it to slow down. So that's always been the way we've talked about it at SuperSpeed. But yeah, I think that is really cool.
Now let's go on to the actual lead wrist angle, because we're looking at lead wrist angle profile and lead wrist angle release. Now, it seems to be a controversial topic to talk about wrist release or shaft release, and I think it's quite easy to define actually when that occurs. And if you look at the 1, 2, 3, 4 profiles that we've got there, you can see how the curve actually travels up very rapidly, and that this is basically the angle between the forearm, as you can see in the diagram on the side, the forearm and the shaft. So the club is setting when that angle is getting less, and it's getting larger when the club is releasing. So in the casting one, you can see that it releases early and just kind of swoops straight up. Whereas the next one, we call it fixed angle. The angle between the wrist and the forearm in the downswing, the beginning of the downswing, stays fixed, and then boom, it releases. Now the downswing loading is actually even better, because you're actually, and this is what Padraig does, and we'll be able to see it in just a minute. What happens is in the beginning of the downswing, that wrist angle is actually decreasing as the hand pulls down, and then it releases. So the benefit of that is you're actually getting a little bit of a stretch shorten going on in the muscles, and you can actually impart more energy into the swing that way. The final one at the bottom, we call it late downswing loading, and it's kind of a combination of the two, the fixed angle and the downswing load kind of put together. It stays fixed for a little while, and then just before release, the wrist angle decreases and then releases very, very rapidly. And so you get that stretch shortened benefit.
Yeah, we see, these patterns with different players all the time. Another cool point here too, guys, is Tyler and I have been doing a lot of research on grip strength, actually strength of players' hands and forearms. That seems to have a major impact on their ability to be able to create downswing loading.
Yeah.
So then we have a whole other webinar on that. If anybody's interested, look up our webinar on SuperSpeed squeeze and grip strength.
Yeah, and I haven't got anything to substantiate it yet, but we're looking into it too. But I definitely think it's the path of the hand as well. It's going to pull down versus throwing out, and several different profiles can change that very rapidly. Anyway,
well, we could have our own webinar on this entire topic, Phil, but I think there also has to do with a lot of the rotation of the club, kind of relative to its center of gravity, that can actually help downswing loading a lot. There's a lot of like typical patterns that we would see with amateur players that, whether it's kind of a chicken or an egg story, like does the face open in transition and cause them to have to cast, or do they, which one comes first is, I think, something there, but there's definitely a whole lot of information. We'll have to do another webinar all on wrists here in the future for sure.
Yeah, I'd love to. We've got a lot of good stuff on the wrist, and the cool thing is that SportsBox can see it and measure it. All right, let's move on.
Yep. So I think this is the last slide you guys have on lead wrist angles. Is there anything here you wanted to add?
Let me see, just a sec. Yeah, we've got Padraig, and then the slide after that is a little bit about our research, and that'll only take a minute or two. So
absolutely. Yeah. Well, you can definitely see this. So when this video plays, this is what we talk about when we talk about downswing loading. So you can see the club kind of stay wide for a long time in the backswing there. And then as it starts down, you're going to see a lot of lag created as the club starts down. And I mean, that's the actual video that we have of Padraig on SportsBox there, kind of showing that data on the left and with all the numbers. So like this is just so cool because it's always been it's always been guesswork for golf coaches to be able to really tell if you're able to do this right. But in these, with being able to use this type of technology, we can actually measure exactly those angles of the wrist.
Yeah, and a little bit of this was very basic research, and I don't think it would pass the mustard for a scientific paper, but it really gives you a little bit of an indication of comparing recreation golfers, long drive golfers, and male and female tour pros to look at the lead wrist lag, if you like, at a couple of different spots in the swing. So at top of backswing, if you look all the way across, the male and the female and the rec golfer, very, very similar. Long drive guys and girls, they take the club way far back, as you can see there. I think that's actually Jamie Sadlowski's from the AMM system and TPI system there. And so you can see that at the top of the backswing, their lag angle is, or the wrist angle is about 69 degrees. Now at the release point, which is the point that I showed you before, where that curve all of a sudden rapidly goes up, you can see that the long drive guys have actually decreased their wrist angle, so they've downswing loaded. The male pros look like they've slightly downswing loaded as well, and so the female pros have too, but you can see the rec golfers have maybe changed it, maintained it a little bit at the release point. And I think normally you'd see, I think this was a mixture of golfers, so normally you'd see that angle getting a little bit larger, which would show you that would show you casting. However, what's really interesting is when you look at the arm 30 degrees pre-impact, that's the upper arm about 30 degrees, probably similar to the bottom right diagram and the bottom two right diagrams that you can see there. The long drive guys maintain that lag until the very last millisecond or a few milliseconds, whereas the rec golfers are 126 at that point. Long drive golfers about 194 at that, 94 at that point. So that's just showing you how the lag works and how the downswing loading works and how long it is maintained until it's released. And we did talk about Bryson. I won't go into that again. His numbers don't show up to be great, but that's because he's got shot shape in mind and got different things on his mind and creates his speed in a different way.
Yeah, like I said, I think that's a big key, is that not everybody creates speed the same way, and knowing how you create speed and where your strengths and weaknesses are is a big deal. Couple new protocols again that are coming, and we have 2 protocols for creating more lag or downswing loading. The first one really works on some simple things just to develop the motor control that you need to create lag. A lot of this kind of has to do with the relation between your hands and how the club is moving and the weight of the club is moving and how that's helping your wrists move. That's our level 1 lag protocol. And the level 2, we start to learn how to do it fast. So we're going to start to do this with a number of different of our drills with super speed shots. We actually add in some counter rotation, which starts to get momentum involved of learning how to use momentum of the club to create lag. We've had a bunch of questions popping in that actually are related to a lot of the drills that I think we're going to be throwing into our level 2 lag protocol here. So that's all pretty exciting. Guys, we're going to take a little time and answer some questions here. So if anybody has any questions, start typing them in. But yeah, great information. Phil and Nate, Paul, I know, Tyler, we went a little bit long on that portion, but yeah, if anyone has any questions on any of the areas here of 3D technology, of how to apply this, how to work on it in your own swing, we're happy to hang around and answer those for a little bit. Also, if anybody's interested in learning more about SportsBox AI or SportsBox 3D Golf, definitely reach out, sales at SportsBox AI. I think they're going to be giving you guys a pretty good little special on a subscription to this app if you are interested. So please check that out. They're one of our partners, technology that we use with every player we work with out on tour. So definitely hit them up with that. Okay, well, we're back here now. We have a couple questions in here, and we'll see if we get many more. I actually want to kind of hit this first one here real quick that's talking about Matt Wolf and, with a club that never stops moving in transition. Phil, I'm curious. How many swings have you seen on 3D where the club ever stops moving for any period of time during the actual swing?
Very rare. Most of the time it actually continues to move. And the way we look at it is you can see that sometimes they have a little loopy move where it comes in, just goes flat for a little while and then starts to come down. And so we've actually been able to measure that in the kinematic sequence. I unfortunately don't have an example of that, but typically what you're going to see is you'll see it jump across the zero line right at impact because it never stops moving. So we define top of backswing not as when the club stops moving, but when the club reaches its minimum speed, because there's a lot of golfers that never stop the club moving.
Yeah, I mean, I would say the vast majority. Like, it's an outlier if the club ever actually stops moving, and even if the club does seem to slow down to a very small point as it's changing direction, the rest of the body is moving very aggressively at that point. So
yeah.
I think that's a big deal for just your average golfer out there, is that there isn't a spot where, like, the top of the backswing, everything is paused and I'm like a statue and then it all starts moving again. It kind of moves in a sequence. Sorry, I'm dying here for a second. Cough attack. Okay. Tyler, you want to hit one of these other questions?
Yeah. So Keith, this one might be an answer, maybe Nate or Phil on this, but Keith was wondering, just as you start reporting things related to kind of hand speed and wrist angles, combination of how the wrist is moving in XYZ, is it just rotation? How kind of does your model look at kind of wrist and hand motion and speeds?
Yeah, that's a good question. I'm not sure exactly which parameter you're talking about, but basically the wrist angle that we measure, there's many kinds of wrist angles, but the simple angle that we measure, maybe I didn't clarify it well enough, but it's simply the angle between the lead forearm and the shaft of the club. So if you were to basically lay a piece of paper right on the forearm and the shaft of the club, draw that angle and measure it with a protractor, that would be the wrist angle at any point in the swing. Now, as far as the speeds, if you like, for the kinematic sequence, the shaft one is the shaft angular velocity or angular speed is very, very simple. Basically, you take the shaft, you draw a line down the shaft at one instant, then you click to the next frame, draw a line down the shaft again, you measure the angle and you divide by the time. So speed equals distance divided by time in terms of rotation. So it's angle divided by time. And that's how you come out with the shaft angular speed curve. I don't know if that's enough to answer your
Maybe the
question.
other one might be hand speed.
Yeah.
Hand speed is linear speed. That's x squared plus y squared plus c squared. The square root of that. I mean, it's just a mathematical calculation of the resultant speed of the hand. And
Yeah,
it's
and
a point on the shaft between the two hands.
Yeah, and that's what I wanted to add here, because I saw when this one popped up as well, Keith. But so one of the aspects, when you're talking about X, Y, and Z, so when we're able to do speed as well, right? Yes, you look for a resultant of a specific key point, right, through a series of time. So with SportsBox, being able to get 6 degrees of freedom as well. If you're looking at just a 2D for, let's say, wrist angle, as Phil brought up, right? You could look at what you believe is the wrist angle, but let's say if somebody is really laying the club off or they're really vertical, that actually changes the true wrist angle versus what it appears in 2D, right? So when you go to 3D data, being able to have that Z coordinate and talk about depth, that's what's able to give us the true understanding of what is the real wrist angle between the lead wrist, or between the lead forearm, and the shaft. That also takes into account whether somebody's laying it off or vertical, right? Yep. But then that question again popped up when you were starting to discuss some speed gains as well, Phil, right? So talking about wrist speed. So that calculation is actually looking at the relationship of the arm with the club, right? So we can see how those are moving in degrees per second. And then you look at the difference between those and what's kind of responsible for the acceleration into the shaft. So, and again, that's all looking at angular speed. So again, that is taking a resultant of the X, Y, and Z with respect to one another to get your overall calculation. So hopefully that helps take that one step further on that explanation.
Yeah, one thing about that I'll quickly jump in since we've gotten so technical here. The pelvis and the chest are different to the arm and the club because the arm and the club are swinging from an end point, whereas the pelvis and the chest are rotating from a center point. So for the pelvis and the chest, we're looking at the rotation speed around a vertical axis that goes through the pelvis and moves with the pelvis. We call that the local rotational speed around a vertical axis through the pelvis and chest.
All right, we're going to dial this back a little notch with this next question. So I love it. You get these guys going. You can get down some rabbit holes real quick. It's fun. So we have a good question here. Is lag angle increased intentionally or passively by relaxing the wrists? This is one that I think we could talk about in another webinar as well. But, I think your traditional idea was that we're going to grip the club extremely lightly, which is going to have very little tension in any of our arms or hands. And then that's going to allow for a lot of freewheeling kind of movement of the club and the wrist. Well, reality is that's not really what tour players do. Let's say downswing loading is a result of good sequencing for a lot of players. Like the ability of that player to start using their lower body well early in the swing while the club in the club's still traveling behind them. And again, that club has momentum, right? As that club's traveling in the backswing, there's momentum. Our body changes direction and is at that point starting to make the club try to go back the other way. But as you saw in that Podrick video, the motion of the body changing direction is causing the club to start to create the initial part of the downswing loading in his swing. And then I think it's impossible to know what's in these players' heads for sure. They're probably not thinking about it at all at this point, but some amount of conscious amount of creating lag is there. Podrick, though, would tell you that what he's trying to do in his swing is he's trying to release the club as soon and as fast and as hard as he can, as early as possible in the golf swing. Which, when you hear that, you're like, well, that doesn't make any sense. You're creating more lag than any player we've ever seen. But the thing is that what that feels like to him is because his body's creating so much speed and that's resulting in so much downswing loading, what he feels like is he's got to get rid of that angle because there's too much of it already and he's trying to get rid of it as fast as he can. So I think that's a very loaded question on the whole like feel versus reality type of debate that we could have. I'm really curious like what you guys have heard from like Bryson, what he feels like he's trying to do versus what he's actually doing and kind of getting into, I'd love to hear your thoughts on that side.
Nate, do you have some info on that?
Yeah, I mean, Paul, I think this might be a good opportunity for you to maybe chime in here of what, again, Bryson kind of is trying to feel versus, what we see is happening.
Yeah, you were in the thick of it right there with him.
Yeah.
Yeah, Bryson is basically, you can think of Bryson's feel for his whole swing as just a big pitch shot. He likes to have an extremely wide arc going back, and on the way down, his feel is to actually drop the arms at a fast pace, but releasing that angle early with ulnar deviation of the left wrist. So he's trying to be extra ulnar very early in the downswing, because that's where all of his input is, and everything that follows is just reactionary at that point, because his golf swing is just a split second. Just to give you guys an idea of his swing speed, from Monday through Friday, his ball speed was cruising at around 185 to about 188, and he was telling me Saturday and Sunday, that's when all the adrenaline just starts to kick in, and it's the same exact input, but I mean his cruising speed was anywhere from 190 to 95, 96, and I can imagine on the course it probably gets even close to 200, especially during those the final stretch.
Yeah, you get a little adrenaline pumping for him. I'm sure it. I mean, that 40-yard bunker shot probably looked like it was 10 yards to him at the end. So
yeah, probably. Probably one of the best shots in golf. That bunker shot, pretty incredible. But it just goes to show, the feels of tour players, how much they differ from the actual outcome. So,
well, I do think it's very cool. But what we've spent a lot of time in on the coaching side of this is that, a lot of times, as a coach, I'm never going to tell somebody to feel something, like that it's going to feel this way, because it feels different to every player. What we look for a lot of times is we look for different drills or patterns that can kind of teach emotion. And then when we're in a session with a player, we're constantly asking them, what does that feel like? Because we want to, once they get it right and do the move that we want, I want to know what it feels like to them. And then Tyler will see me on a broken record just saying that same thing. Oh, feel this, feel this. Once they've told me what it feels like, we're just trying to ingrain that and get them to be able to repeat it. So yeah, I think there's a lot to that. Well, I think we're out of questions. Guys, I really appreciate it. Again, Phil, it's always great having you on. Just, I feel like this is like going back. We go back a long way at this point. It's a lot of fun to talk with you, and Nate and Paul, great information you shared. I really think it's great. And Tyler, always great to see you here too. I think there's way more that we could talk about, and we'll have to do something like that in the future. Make sure that everybody out there, you are ready and you're, staying on the alert here for some of those new drill programs coming out from SuperSpeed. We've also got some really cool new products coming out this fall, so stay tuned. And we hope to see you at another webinar very soon. Thanks everybody, and we'll see you later.
Yeah, that was a lot of fun. Thanks.
Thank you, everyone.
Bye, everybody.